It is often said the measure of a man is not where he stands in times of comfort and convenience, but where he stands in times of challenge and controversy. Max Ludwig Planck saw plenty of challenge, seeing all his kids in caskets, the tragedy of both world wars, and the twisted shape his beloved homeland took during the Third Reich. He stood throughout with the integrity of academia and his enduring love for physics, to which his contribution is the measurement for which he is eternally known. Notably, he discovered what is now known as Planck's constant. It was predicted that a perfect black body would emit radiation of all frequencies, increasing in intensity for higher frequencies. However, experiments showed a very different distribution of intensities. This was called the ultraviolet catastrophe. In 1900, Max Planck offered the first explanation by relating the energy of a photon to the frequency multiplied by a constant, h. He also gave an equation for the intensity of blackbody radiation, from which we are able to calculate a value for Planck's constant experimentally. In this experiment, the soldering iron is the most obvious safety concern. Caution should be taken not to touch the iron tin as it operates at 400 degrees Celsius. The same care should be taken to avoid touching the bulb, which can get hot. The solder is lead-free but should be handled with pliers and hands should be washed after use. The extractor fan should be used to disperse nauseous solder fumes. Goggles should be worn during the entire soldering process. After collecting data, we use Stefan's law and the assumption that T is approximately equal to R to the power gamma to arrive at this equation. A rearrangement of this allowed us to plot a graph to find gamma. Then we calculated the temperature of the lamp and used this to plot a graph of a rearrangement of Planck's law. The gradient allowed us to calculate a value of h, which was 6.6 plus or minus 0.3 times 10 to the negative 34 joules seconds. Planck's constant was the turning point from classical to quantum physics, as its solution to the ultraviolet catastrophe showed that light carries energy in discrete packets called quanta. To improve, we should find a more accurate way to model a blackbody and measure the resistance in the circuit. During the experiment, we developed a new skill, namely soldering, which will be useful if the circuitry work in the future. Despite the challenge, we successfully found the measurement of Planck's constant.